Hi everyone, welcome to today's session on AI/ML for product leaders and product managers. The topic we are going to talk about today is called semantic cache. To be specific, this is the term very frequently used when we talk about RAG, called Retrieval Augment Generation or embedding models. We'll talk about how semantic cache is something that can be used in our daily life, considering a use case for product managers. We'll talk about its architecture and we'll wrap up with by taking the comparison of the metrics that we get if we implement the semantic cache in our regular workflow. So before we talk about the architecture, let's switch to the basics and understand what's the exactly need for the semantic cache and how it got evolved over the period of time. So if you talk about semantic cache in LLM, we can understand this is a mechanism that is used to reduce the cost and latency by making the by leveraging the intelligence of the caching mechanism. That's a very old and known thing from the perspective of when we talk about caching. It's something that is we have been using for ages for improvising the response time. Same thing we are leveraging, but in terms of vector embeddings and for the LLM models. So let's switch to what exactly it is. Semantic cache, it stores and reuses LLM responses based on meaning, and not exact context. Basically, semantic cache used to get the logical understanding of the different phrases and consider them as same or similar. Means we are not comparing the exact content. We are evaluating the meaning of the sentence per se. If you say what is the capital of India, or you can say tell me about the capital of India, or name me what is the capital of India, for instance. All these three have the same meaning, though the content is not same when we are looking at the words. But this is how semantic cache used to determine the similarity across the different queries, which turn out to be logically same. And this is the reason we call it semantic, means similarity. And behind the scene, it uses the vector embedding to represent our query intent and context. For instance, we can say whenever we make a query, it saves that into numerical representation that is seen as a vector represented in the n-dimensional space. And its context is also determined using the LLM model itself. Now, LLM model here is that is specific to the embedding that we are going to use. And eventually, it's going to reduce the API call over the network, and hence the latency for the similar set of queries would be mitigated up to a very large extent. We'll talk in detail on all these aspects in the forthcoming slides. But before that, we'll talk about what is the traditional cache and semantic cache. So the traditional cache is something where we make a cache hit when the exact keyword matching happens and not based on similarity. And also it has high cache misses because it looks for the exact same sentence or exact same content, basically you can say, and it will cause the redundant LLM calls. Here we are talking in the context of LLM itself. So if we use traditional cache, we might not get the same query, considering, as we have taken the example, the same question can be rephrased in different ways, and when it's done it rephrased in different way, it won't turn out to be a same content, and it will have a miss. So eventually it will end up with making a call to LLM. However, in case of semantic cache, we are doing meaning based. We are evaluating the meaning of the query and it's considering them as similar if they draw out the same meaning. So that leads to high cache hits and thus reduces the API calls. And the operational cost of the inference that comes with the LLM model can be addressed. Let's take a high level understanding on how it actually works behind the scene. Let's say the very first time our LLM model receives a query. Here LLM we can visualize like any, for instance, ChatGTP or Perplexity or any sort of model that we have in the market. All works on the same way, on the same pattern. Consider we have any of those LLM model behind the scene. So, but when semantic cache comes in picture, how it works? The very first time we are putting a query or prompt, means user submits a question. He's asking a question here. So it goes and it query gets converted to vector using embedding models. So when it gets converted using embedding model, it's get represented as a numerical value in that space. Now, whenever forthcoming query comes, we do a vector similarity search. Means it compares the query vector. Means vector here is not the exact meaning, is not the exact string, but it based on the meaning it generates the vector. So it's intent or context specific search. For example, if we talk about bank, if the bank here context is the related to river, then it's in different context. If you're talking about a financial institution, then bank is a different. So both have different context of being bank or being something done with the riverbed. So that context is also interpreted by the embedding models. So based on the context is the first layer, followed by understanding the exact logical meaning of the query. Combination of both turns out to create a vector, and hence we do the vector similarity search for the forthcoming questions, and that determines whether it will have a cache hit or cache miss. So if the similarity that we have defined, it's defined by the rule engine. If it's turned out to be greater than the threshold, means we get the cache hit and we'll give the response from the cache itself. So if you talk about the architecture, as we just discussed, architecture would be like the very first time we make a query, it creates the embedding. Embedding is a numerical representation for the string or the text, gets saved into vector database. That could be Redis or Pinecone, and we get the response whenever we get a hit for the cache for the subsequent queries. So in this slide we'll be talking about the use case, like if we are going to do a rapid product prototyping. If we talk about like a product manager, he got an idea and we are thinking, okay, I want to try it out as a product. We need to look what is the engineering feasibility and what would be the viability from the from the management perspective. So in interest of time, we can leverage this semantic cache so that it will save the time and we can do the quick check before we put it across to the management. So we take a use case here. Since the building AI prototypes are expensive because we can't afford to have multiple LLM API calls during iteration, multiple iteration. We want something, or we want an workaround that can impersonate as an LLM API call. So the solution turns out to be a semantic cache, because that enables cost-effective rapid testing. Because it's something we are testing in iteration, and we need not to get the query or our question or the prompt get evaluated again and again through the API. The same thing can be done from the cache itself. So what it do basically, it allow an end user or the product manager or leader to test different UX or UI flows without rerunning the expensive LLM inferences. Just try to fit it better here. Okay, so it reduces the prototype development cost by 70% because we don't need the operational cost of setting up the our model in the inference itself, and if a person can focus more on product logic rather than LLM costs. So if we talk about the if we compare what do we attain by using semantic cache, or in other words, what do we miss when we don't use the semantic cache? We see without semantic cache, our query, for example, it's like we just make a simple query of like summarizing queue for spending. So we are costing per API call $0.10. These are just for illustration. Let's consider it's $0.10 per API call. But if you are doing the caching, we are just spending $0 because it's cached. Now, if you have 10 iteration, it turns out to be $1 cost. But here, even if you are doing 100 iteration, you're having hardly zero point 0.3 or very minimal cost basically. And when we say it's with the iteration, since this is something without caching, it turns out to be expensive. We have to be very cautious, and it slows down the iteration. However, using semantic cache, the 97% cost reduction is there, and we can do rapid iteration by using the cache and not bothering about the cost that comes with the inference engine. So if we talk about the benefit that we can attain, is we generally get the response time that's 100 times faster. We got the cost reduction to up to 70% because we are making very fewer API calls, and it's also the time to market turns out to be 3 times faster because their iteration is fast. We can come to the conclusion of an idea whether it's going to be a valid one to take it further, or we can drop it there itself. Or in case that turns out to be what fits well with the business viability and the engineering feasibility for that idea, thing will go fast and we can have faster time to market. So if we say how we need to use the semantic cache, these are the major points that we need to consider. So first of all, we need to choose the embedding model that will create the semantic cache, or the embedding basically that we talked about, means representing data as numerical value. So mostly it's like all MPNet based v2 is recommended in most of the use cases, very easy to use in local. We use vector database. Redis can be used for prototyping and Pinecone for scaling. Then we can go with we need to define a rule engine, or you can say a threshold. 0.8 is something that's preferred for high precision, because here the comparison is being done based on the similarities, not the exact content. But we need to see whenever the subsequent query turns out to be 80% of what exactly we have said the created the embedding for, we consider it same, so we conclude it to have a cache hit. So this is something critical. We need to understand that varies with respect to the use case, and we can simply integrate this with the LLM framework, LangChain, or using Spring AI, so that in case if we have a cache image, we can directly go over the network to our inference engine. So basically, if we talk before we wrap up, we would just like to take the primarily key takeaways for this our talk. Semantic caching basically implements or enables us to have a rapid, cost-effective AI product prototyping, reduces cost by 70%, and iteration becomes 3 times faster because we are not making any API call yet again, and scalability turns out to be 10 times what we do traditionally basically. So these are the primary key takeaways. So I hope this discussion might turn out to be fruitful to all of us, and I'm very soon will be bringing up another session on LLM inference and what are the restrictions that we see in the current market, and what option do we have, and how we can leverage VLLM to be specific. That's an offering from, it's an open source project from Red Hat. That would be our next talk. Thanks for being there.